These are the solutions for the study guide for for the 17th test of algebra. And let's take a look at our first problem here. And it says that we're supposed to multiply this binomial by a trinomial. So basically I'm taking the x and multiplying it over each of these terms. And so for my first part I get x to the third power, and then minus 4x squared, and then a positive 3x. And then for the next part, I multiply the 4 by each of those terms again. And when I do that, I'm going to line up some terms as I go ahead and write the ones underneath of the ones of the same variables raised to the same power. So first one I'm going to write down is 4x squared. That's the 4 by the x squared. 4 times negative 4x makes a negative 16x. And then 4 times 3 gives me 12. And so I'll add these numbers up, and I'm left with x to the third. The 4x squareds cancel out. They're the same number but opposite sign. And over here, I'm left with a negative 13x, and then I just bring down that 12, and that is the solution. So the next problem is just using FOIL, first out, inner, last, and 3x and 3x makes 9x squared. 3x and 2 make 6x, and negative 2 and 3x make a negative 6x. Negative 2 and 2 make negative 4. So you'll see when I have a sum and a difference, same numbers, just opposite sign in between, you'll see that the outside terms and inside terms will cancel, and we'll be left with this, 9x squared minus 4. On this term, or this problem, I am going to rewrite 5x plus 1. I'm going to write it twice, because when you're squaring a binomial, you need to make sure you check those outside terms and inside terms, get those done. So 5x and 5x make 25x squared. The outside terms and inside with a binomial squared are going to be the same. So 5x and 5x for the inside and outside terms, and the last terms just make 1. So adding these two terms together gives me 10x. And then I just bring everything else down, the 25x squared and the positive 1. So moving on to my next problem, I've got some factoring to do. So what I have to remember about factoring is, though, this last term tells me I need to add the outside terms and inside terms, and they'll make a positive 13x. And so I know that my first terms multiply to make x squared. My outer and inner terms are going to combine to make the 13x. And the last terms are going to multiply to make 30. So when I go ahead and write it out, it's going to be x and x that make x squared. The numbers that multiply to make 30 are going to be 3 and 10 this time. And I know the signs are both positive because they multiply to make a positive and add to make a positive. So always check your work. Make sure it matches the answer. Or the original problem, 3x and 10x do add to make 13x. And so again, I know the first terms make x squared. Last terms make 30, and so I've checked the problem off, so I know this is the correct solution. Over here, I've got a negative sign, so that tells me that the outside terms and inside terms are now subtracting. So outside I want to write first. So outside and inside subtract, and they make a negative 3x. So I go ahead and try it. And it's the same thing. The first terms are multiplying to make x squared, so it's got to be x and x. And the numbers that multiply to make 108, well, try 12 and 9. And those will end up working if we make the 12 negative and the 9 positive. So let's check it out. Negative 12x, positive 9x, and those will add together. In this case, subtract because they're opposite sign to make negative 3x. First terms, again, are x squared. And then we got the plus negative 3x there and the minus 108. So it does match. And so we know this is the correct solution. So let's take a look at our next three problems. So more factoring, just a little bit tougher because now we've got the coefficient in front of x squared. But it's the same sort of thing. We know that since this is a negative, the outside terms and inside terms are going to subtract to make negative 1x. So I know only 2x and x make 2x squared. The only numbers that multiply to make 1 would be 1 and 1, so this one's not so bad. So numbers, to make it a negative x, I'm going to put the minus sign here and the plus sign here, but check your answer. Make sure it matches. So 1x, negative 2x, you see those will subtract to make negative 1x. So it does end up working out. See, I have the 2x squared for the first terms. Middle terms, again, middle term is made by the outside terms and inside terms. We just saw that. And the last term there makes negative 1. So I know it checks out. So this is the right solution. Now looking at this one, another one that is fairly doable here because we have an odd or prime number as the first and last term again. Outside terms and inside are going to add to make 5x this time. So outer and inner add to make 5x, and I'll go ahead and put in the plus signs. And to make a 5x, I'm going to put the 2 here and the 1 over here. So again, check your work, see if it matches. So if I hadn't put the 2 in the right spot, I would not have gotten 5x. I would have gotten 7x that way. So check and make sure it matches. Again, you got 3x squared for the first term, 5x for the middle term, and positive 2 for the last term, so I know I am correct, and I can go ahead and box the answer. Sixth problem is going to be a little bit tougher. It's got tougher numbers because we don't have the prime number as the first or last term. But I do know, since this is a plus sign, that tells me outer and inner are adding together to equal 78x. And so when I go ahead and do this, I can start by drawing the 2 sets of parentheses. And I know both signs are positive, so I can put those in there. And now I just need to find out numbers that multiply to make 27. And I'm thinking I'm going to break it down, probably to 3 and 9. Because 9 times a factor is going to give me something pretty close to 78. And I can get one really close to that if I make this 8x and this one just 2x. And you see that ends up working because 8 and 9 make a number pretty close to 78 but smaller. And that's the key. When you're adding together, they need to be smaller than the middle term. The factors do. 72x and 6x do add to make 78x, so that does end up working out. And again, I've already checked the first terms make 16x squared, last terms make 27, so yes, it does check out. I know this is the correct answer. So looking at our last 3 problems, we've got some word problems here. It says Al's mixes a 35% salt solution with a 10%. And so what we're trying to find is the number of liters of each. And so I'm going to say X is the number of liters of the 35%, and I'll say maybe like Y equals the liters of the 10%. And so reading on further, it says the mixture produced 40 liters of a 20%. How many liters of each are required? Okay, so what we're going to do is make a quantity equation and a value equation. I'll start with my value equation. I'm going to take the decimal form of these percents. 35% is 0.35. Since I said that X was the liters of the 35%, I'm going to put 0.35 times X. That's going to give me the amount of salt in that solution, or in that part. And then I'll take 10% salt solution, so 0.1 Y equals 40 times by 0.2. And so my other equation is just going to be my quantity equation, X plus Y equals 40. So I'm going to go ahead and multiply this one by, let's go with a negative 0.1. That'll be easier. And it'll cancel out the Y terms. So I'll go ahead and multiply. I got negative 0.1X minus 0.1Y and equals 4, negative 4. And when I go ahead and multiply these out, I got 0.35X. And again, this is 0.1Y. That's going to be a plus sign there. And then when I double 4, I get 8. And then add the 0, but then move the decimal back, you just get a positive 8. So when I add this together, this gives me 0.25x equals 4. The y's cancel out. I used elimination there. And so I'm going to divide by 0.25. Now when you do that, just add the 2 zeros here, and the decimal point will move over. So it's really 25 into 400. And 25 goes into 400, we have 16 times. So X equals 16. So 16 liters of, and X is up here, it's the 35%. That's why it's important to make sure that you write down what your X value is and what your Y value is. It makes it easier for the reader too. Gives me a chance to see if you're doing it right. And then all I have to do is subtract the 16 from 40. See, if I put that back in place of the quantity equation, I'd have 16 plus Y equals 40, so subtracting the 16 from both sides will give me my Y value. And go ahead and borrow a little bit so you can see how that makes 24. So y equals 24 liters of the, and this was the 10%. So taking a look at the other problem, it's very similar, except in this last case we were given a known amount of mixture. Here we're given a known part. So it says Sue mixes 60 liters of a 13% solution with a 30% solution to make a 20% solution. So we're supposed to find out how many liters of 30% alcohol solution were required. So let's call X equals the number of liters of 30%, and we'll have to assign a variable for the 20%, so I'll just call it Y, liters of 20%. And so when I set it up, it's going to be the same sort of thing, except this time 60 times by 0.13, that is a part that's given. And so we have X times by, and then 0.3, and then this all equals Y times by 0.2. And so my other equation is the value, or the quantity equation, how much we have. So 60 plus X is going to equal Y. So I'm going to use elimination again. I'm going to go ahead and cancel out. I want to keep the X's, so I'm going to cancel out the Y's. Even though it's a good substitution problem because I got Y by itself, I'm just going to go with elimination here. Either worked pretty good because I got equal signs, X's, Y's, constants all lined up, so I just figured I'd use that. So this is going to give me 12. 6 times 2 is 12 with a 0, but then you move the decimal back, makes a negative 12. And then plus 0.2x, and actually that should be a minus sign, so let me fix that real quick. So minus 0.2x, and then equals negative 0.2y. And so over here we're multiplying, and when I do 60 times 0.3, I got 7.8. And then a plus 0.3x equals 0.2y. So when I add these together, the y's end up canceling. Now you got to be careful here. You got 0 on one side of the equal sign, and I have 0.3x equals, and then this gives me a negative number, negative 4.2. So this should be a plus sign there, so let me fix that. And from there, it's a positive sign because I got more positives than negatives. So I'm going to move the 4.2 over, or I could have moved the 0.3x either way. And so I'll move the 0.42 in this case, and so I'm adding it to both sides, and that's how I get it to be positive. So I got 0.3x equals 4.2. So when I do that division, 0.3 does go in there evenly. 3 goes into 42. We have 4, let's see here, we have 0.3. And oops, I see a mistake I made. I forgot to subtract right here, so let me go ahead and do that. So let me fix that. 3 does go into 42 evenly. I'm glad I didn't do that because I see I made an error. So I forgot to subtract the 0.2x, the negative 0.2x from the 0.3, so that makes 0.1. And if I divide by 0.1, that's even easier. It just moves the decimal over, this one as well, so x is going to be 42. So 42 liters of the 30%. That's what X represented. So moving on to the last problem here, and this one says that it's a coin problem. We're trying to find the number of nickels, and I'm going to call N equals the number of nickels. And we'll go with quarters, so we'll use Q, number of quarters. And it says that the coin bank contains 63 of those. So the number of nickels and the number of quarters equals 63. And the total value is $9.35. The value of a nickel is 0.05. Make sure you put the 0.05 there, not 0.5. That would be a 50-cent piece. This is going to be 0.25Q equals $9.35. So I'm going to just cancel out the 0.5. That'll be easier, or 0.05 that is. So I'll multiply every number there. So I get negative 0.05 N, and then minus 0.05 Q equals, and then 5 times by 63 gives me 315. So that's going to be 3.15, and that'll be negative. And so when I add these together, I end up getting a 0.2Q equals, and then here the nice thing is I end up with a 6.2 when I do that subtraction, and then I can go ahead and do that division. So divide by 0.2, And it moves the decimal over again, both the numerator and denominator, so I end up with Q equaling 31. So 31 quarters. That's part of the answer. So let's take a look at the other part. I need to just substitute that into the quantity equation. I've got n plus 31 equals 63. So just subtracting 31, that part, from 63, the total, will give me 32 nickels. And those are the types of problems you're going to see on the test. Good luck.